So in this last section of the behavioral model 4, we'll discuss the rest of the section. That's decision statement and looping. They're pretty much similar to any other high-level language like C or Java. So we have best thing is to see some example like if then else. So we have something like if not locked, then some registers transfer statement enable. So these are all direct checking, this is assumed to be binary or 1-bit values, and then depending on 0 or 1 it just evaluated to true and false. I guess we can also use multi-bit variables here like 8-bit or 32-bit. In that case it just look for the decimal value 0 or non-zero for checking true or false. And then we have the usual like a condition kind of stuff, less than equal something, do some begin. And so if we need to pack multiple statement, we definitely need to do a begin and end block. Unlike this one, this statement is just one statement, so we don't need a begin and end there, or one single statement. But for multiple statement to put together under one block, we need to confine that within begin and end. Else we can put on begin and end also in a block if it is multiple statement, but here only one statement, so we can do something like that. And this is like if value control equals 0, then do something, and so on and so forth. And then we have this else if, and else. Here one point I would like, if this is a real like bit values or a variable like an range or output input or where, though for those cases I would definitely encourage you to use the triple equal values, because they're the true comparison and they handle these high Z and unknown X state. So that's better from that perspective. But if this is a simple like other type of variable like integer and things like that, which is just for making the test bench, implementing the test bench itself, like the test of the test bench itself, nothing to do with the corresponding hardware and stuff like that, it's just for the simulation, then you can use this double equal things there. Now this case statement, this is you're much more familiar with so far with the project 1. This is an example. This is a sensitivity list for this always block. Within the block we have started and case on the operation, and these are the different configuration value of the operation 1, 2, 3 in the hex, and this is the action. Okay, and there's a default flag, which is if it doesn't fall into any of them category, then what is the default value is going to be. This one is important in terms of defining the hardware behavior. If you don't define it, either compile time or maybe in the runtime it will give you some error or warning. Okay. But if you think of from the hardware perspective, there shouldn't be any case left within a case statement, because in real life scenario all the things can be possible, right? So at least if we don't want to encode all of them, all of the possibilities, and if we know that only these three are the only one, we need to have some definite action and every other thing falls into one common operation, then of course you want to have this default clause there, and define what is the action corresponding to the value of the operation in this example, which doesn't fall into category 1, 2 or 3. Okay, and here is another note, this is single statement example, but if you want to pack multiple statement for the one case, just start like begin block and end block, and then you can pack multiple statement within a case statement. Now looping, while loop is similar to what we do in C or Java. We define a variable, possibly integer, let's say for this example, I guess it has real type data which is corresponding to the floating point, and so on and so forth. Just look at the book that I refer for the learning Verilog. It has very nice description of what are the variable types and what you can use and what are the usage scenario, etc. Anyway, so we initialize the count and start a loop while count less than 128, of course, and then within a pack we just display that number and increase the count. Just this block is an example. So it will go and execute this block till count is 127. After that it will just go out of the loop. For statement is very similar to C or Java. We have the integer, and then for initial statement, the termination condition, and the incremental statement. So, and then here is an example of one single line. It's the same equivalent code to this one, right? It's printing a count of from 0 to 127. Is the same thing, 0 to 127. You just print the count, one single statement. Again, if you want to pack multiple statements, just start a begin and end block there. Repeat loop, I forgot if C or Java has that. It might have. If it is, I haven't used it for long, definitely, because I couldn't recall if it is there, but definitely there is another language called BASIC. Beginner all-purpose symbolic instruction language is pretty like toy languages we used to have back in 80s. That used to have this repeat thing. It's in a different form though. Well, now what it does is basically is similar to the while, but it's stating it very straightforward. Okay, repeat this block for 128 times. Okay, so effect will be same as this for loop or while loop. It will just print count 0 to 127, and it will just repeat. This block will be repeat for this constant number. I believe we can use a variable here also, like repeat. Let's say we define another integer limit and initialize that to 128. Then we can do a repeat limit and then this block. It should work. I don't see any reason it shouldn't work. Just try it, experiment that, and see if that works. If not, let me know. Forever statement is almost like a always loop, like while one loop. It is. This is an example of like clock generation we are familiar with. We are defining a range, clock 0, and remember, like we used to have the always some number of second clock inverse clock, and in the initial block we used to initialize it as clock equals 0. Now we eliminate that always block. Everything we are doing in the initial block, that the initial begin clock equals 0, and now we do a forever. So this guy, even initial block is executed at the beginning, time equals 0, but since we have a forever here, so this specific statement will be just running forever, like till the end of the simulation. So what it tells now forever at each 10 nanosecond interval, make the clock to its inverted values. So it will just produce a clock of, I think, 20 nanosecond period. So this is a forever loop. Sometimes you might want to use it for certain purpose. So it's just in any other, like any other programming language, you have so many decision making style and statement. Depending on what's your target application and what you are going to write, it depends on that. One style of writing might be easier from the coding perspective than the other style. Like one style of looping might be easier than the other style, but it's absolutely fine what you code, whether you loop it with the for, loop it with the repeat, loop it with the while. It doesn't really matter as long as it's looped correctly. So it's your convenient to pick up things when you are writing. There is no straightforward rule of which one you need to or should use and which conditions. uh, One style of thing might give you less typing than other style for certain scenarios, but you need to decide that yourself. Okay, I guess this is the end of that VWL modeling. So this is, after this you should be fully prepared to write and complete your project too. Okay, so we guess we are done here for the behavioral model. We'll start gate level modeling after this. But that will be needed much more later in your project 3. Okay, so we'll come to that point. So this is end of behavioral model. There is nothing to learn beyond this point, which is needed for your project 2. So if you have any question, please feel free to ask me over Canvas discussion or in the class. I'll happy to answer.